All right, so now we're going to start with a few notes here in Chapter 6. We just went through and kind of picked out some of the sections that are important. So um, basically, a lot of stuff in this chapter is dealing with polynomials of higher degree. So anytime you need to pause the video, rewind, go through the examples again, anything like that that you need to do, you go ahead and do that. And if you're still not sure about something, send me an email, send me a comment on Classroom, and just let me know. So all of these videos are going to be uploaded to the Google Classroom. They'll also be on the YouTube link. So these notes are also on the Classroom, so you can fill them in, or you can just follow along, and you'll get some examples for your homework. So we're going to do this basically just like we would do if we were in class. We're going to start off with a couple bell ringers. I'll go over two examples, and then I'll leave you guys. I'll suggest that you try the last two on your own, and then pause the video, try those examples, and then unpause it and check your work with what I do. So combining like terms. Again, when we're combining like terms, we're basically looking for some terms that have the same variable and the same exponent. So if we look here, we have a 3x, 5x, and a negative 7x. They all have the same variable, same exponent. So we could just combine the numbers out front. All right. So 3 plus 5 would give us 8x minus 7x. And then again, combining the numbers out front, 8 minus 7 is just going to give us 1x. So you can just write 1x, or you can write x, is really the most algebraically correct way of writing that. So there's your first bell ringer. Second one over here, again, same variable, same exponent. So if we look at this first one, we have negative 8x y squared. None of these other two terms have a y squared. They got an x squared, but they don't have a y squared. So this term right here does not have any other like terms. So that one is just going to be left by itself. But these other two are like terms because they have an x squared and they have a y. So they got the same variables, same exponents. So we will add those together by combining the numbers out front, right? So negative 2 plus 5, that's going to give us 3x squared y. And then I'm going to write that negative 8x y squared after that, okay? Next example down here, numbers 3 and 4. We want to just determine the number of terms. So I want to know how many terms are there. Is there 1, 2, 3, 4, 5? How many terms are there? So your terms are separated by plus or minus signs. So if we look at this, 1/2 BH, you might think, well, there's three terms. There's a 1/2, there's a B, and there's an H. But this is all one single term, okay? You don't see any plus or minus signs in here. So this is just one term, okay? So this, I don't know what's happening there. Let me erase that, fix that here. This example number 3 right here, this just has one term. Okay, there's no plus or minus signs. Now jump over to number 4 here. We got a minus sign right here, and we got a minus sign right here. So that means there is one. Let me switch up this color here so it's not blending in there. We got 1, we got 2, and we got 3 separate terms here. Okay, so there are 3 terms in number 4. Okay, so again, if at any time during the video you need to pause, rewind, check that example again, you feel free to do that. I'm just going to keep rolling with it from here on out. So in any of these videos, if you need to pause and rewind, you do that. So let's just keep going. All right, here's your notes. Again, what we're looking at is the degree. Basically, all the degree is asking for is your highest power. Okay, so if we look at this polynomial that's listed down here, the degree here, highest power, would be 3 because that's the highest exponent. That's literally all that word degree means. We talked about standard form before. We talked about that with our quadratic functions, writing them in standard form. Just means highest power to lowest power. Here's another fancy way of saying that. That just means descending order. That's all that means, okay? It just means highest degree to lowest degree. You see that written over here. It just means highest power to lowest power. Again, just a bunch of words that mean the same thing, okay? Here's a table we're going to fill in here, all right? The degree Degree just means, again, highest power. Right here, the 6, again, we're looking, degree is referring to the highest power of your variable. All right, so if there is no variable, remember we talked about this before, this is just a 6. That means it has an x to the power of 0. Remember we had talked about that before earlier in the year at some point. So that means the degree, your highest power, is 0. All right, to name that using the degree, well, 6 never changes. 6 is always a 6. If something never changes, that means it is constant. All right, number of terms, this just has one term. If something only has one term, that is called a monomial. Monomial. I'm going to try my best to write legibly in here. This is kind of different for me to do this here, but I'll do my best. Your leading coefficient, that's basically just your number there that's in front of the variable with the highest power. In this case, we only have one term, so our leading coefficient is a 6. All right, switch up my color here. Next term, our polynomial example here is that x plus 3. All right, so x plus 3, the degree, your highest power of x right here is just a 1. So the degree, the name using that degree is linear, right? Those are linear functions. You guys graph those in Algebra 1. Your y equals mx plus b. That's linear. The number of terms, that has nothing to do with the degree. You could have something that's linear and it has one term. You could have something that's linear and has 2 terms. It can't be linear and have more than 2 terms because you just can't have that. So this has 2 terms, right? 2 terms. If you remember the prefix for something that means 2, like those things you ride that have 2 wheels, that's called a bicycle. The prefix bi. So this is called a binomial. That's what that prefix bi means. It means 2. Binomial. The leading coefficient, that's just the number that's out here in front of your x, and that in this case is just a 1. Let me switch up my color here so we're not running together. Polynomial example here, the next one, polynomial example, 3x squared. The highest power here is a 2. That degree, the name using that degree with our highest power there is a quadratic. I'm going to just abbreviate that quad. Well, I might be able to fit that in here. Quadratic. Yeah. Number of terms, there's only one term there, so that's 1. We name that one up above there. That is still a monomial. Right? One term is always a monomial. Doesn't matter if it's a quadratic monomial, linear monomial, constant monomial. One term means monomial regardless. Doesn't really make a difference how many or what the degree is. It's always a monomial if it has one term. Leading coefficient, again, your term there in front of your x squared is a 3. All right, so next up is 2x cubed minus 5x squared minus 2x. So the highest power we have here is a 3. All right, so highest power is 3. That is called a cubic. So we got a cubic function. We have 3 terms here, so the number of terms is 3, and that is a trinomial. The leading coefficient, again, that's the number in front of your variable with the highest power. That's a 2. So we got a 2 there. All right, we just keep moving along here. Degree, the next one here, we got x to the 4th, so the highest power is 4. And the name using that degree, so whenever we have something with the highest power of 4, that is called a quartic. So Q-U-A-R-T-I-C. If you can read that in there, hopefully. Q-U-A-R-T-I-C. Quartic. I'll try and write it a little better. Q. There we go. That's nicer. All right, so number of terms. We have 2 terms. We named these already. These are called binomial. And the leading coefficient here is a 1 because we have 1 in front of that x to the 4th. All right. Last one here to fill in our last table here. Highest power is a 5. So highest power is a 5, and that is called a quintic. 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 Now there are 1, 2, 3, 4 terms here, and whenever we have something where the highest power gets above a 3, we don't really have a special name for that. We basically just say polynomial of degree 4, or I'm sorry, not degree 4, of 4 terms. So that's all we're going to say here is polynomial of 4 terms. Oops, sorry. Polynomial of 4 terms. Okay, and you would do that for anything above that. Polynomial of 5 terms, polynomial of 6 terms, 7 terms, 8 terms, so on and so on. Leading coefficient here, the number in front of the highest powered x is a -2. All right, so 1, 2, 3, those number of terms have special names: monomial, binomial, trinomial. But anything above that have, you basically just have a generic term there, polynomial of 4 terms, and so on. All right, there's your table. Now we're going to get into our examples. And again, I'm going to do these two with you, and then I'm going to flip over to the next slide. I recommend that you pause and just do those real quick on your own, and then just come back and make sure you got the right answer. So first thing we want to do here is we want to put these in standard form, so highest to lowest power. So that means we're going to take that 5x to the 4th. So we're going to say 5x to the 4th. We're going to put that first, minus 7x. And then we will classify it by degree and number of terms. So the degree here is 4. So that means it is quartic. So Q-U-A-R-T-I-C. 2 terms, binomial. All right, that's all we got to do there. Next one, again, put it in order from highest power to lowest power. Also, keep in mind, we have 2 like terms here. We got a 4x and we have a 2x. So we want to combine our like terms while we're doing this as well. So 3x to the 3rd plus x squared minus 2x. Okay, negative 4x plus 2x gives you that minus 2x. So make sure you're combining your like terms while you're doing this also. All right, so highest degree, highest power here, x to the 3rd. So that means that this is cubic. 3 terms, 1, 2, 3, trinomial. So these two examples, what I suggest, pause it, do them real fast, and then come back and make sure you have them correct. Okay, just like we would do in class. That's what I would suggest you do right now. All right, so hopefully you did that and you're back and you're ready to try these, or you're ready to check your answers on these. Hopefully you did these on your own and you're ready to check them. So combine your like terms on those first two. 4x minus 6x is a negative 2x plus 5. The highest power here is 1, right? Our highest power here is x to the 1st, so that means it is linear. 2 terms means binomial. All right. Second or fourth problem here. Again, we got like terms. 3x to the 3rd plus 2x to the 3rd gives us 5x to the 3rd. Then we have our plus x squared minus 4x. Highest power is 3, so that means it is cubic. 3 terms, again, trinomial. All right, so there's your notes for 6-1. Again, beginning of the section, all we're doing is naming things, not really a whole lot of math going on, renaming things, combining like terms, rearranging things, putting them in order from highest power to lowest power. That's pretty much all there is to this. So it's a pretty easy start to Chapter 6. All right, if you have any additional questions, either send me a comment on Google Classroom, or you can always send me an email, and I will get back to you as soon as I can. So go ahead and try those homework problems, and again, the answers will be out then later on in the week. All right, thanks.